Welcome back, students. In this class we continue the mensuration chapter 11 exercise 11.3 question 5. In the previous class we completed this four problems, four problems. In this class we will continue the fifth one. The problem is Daniel is painting the walls and ceiling of a cuboidal hall with length, breadth and height of 15, 10 m and 7 respectively. From each can of paint, 100 m square of area is painted. How many cans of paint will she need to paint the room? So we have so many. Daniel is painting the room which is of cuboidal room or all of cuboidal shape, which is having length, breadth, height of. So we can write this diagram like this. Cuboidal will be just this form, vertical or horizontal. So now this is a cuboidal. So I'm writing just roughly. So this will be in this form I have written, and so this one will be length, and this is length, this is width, or we can also name it as breadth, and this one is height. So this is a cuboidal. So next, what is the problem given is? They have given length is equal to, these are the data, 15 meter, breadth is equal to 10 meter, breadth, or we can also write this one as width, and also height as 7 meters. So from each can 100 m square of area is painted. So now we have to find out how many cans she is using. So a cuboid, first see, a cuboid is having a 6 rectangular faces. A cuboid has 6 rectangular faces. So therefore surface area is calculated using the formula, that is 2 into L into length into width plus 2 into length into height plus 2 into height into width minus length into breadth. So this can be replaced as 2 into L. This width can be written as breadth plus same thing, height h plus 2 into h into b minus length into breadth. So surface area can be calculated using this formula. We'll substitute all the values, that is 2 into 15 into 10 plus 2 into 2 will take outside. So we'll take 10 into, write 10 into 7 plus 7 into 15. This is m square, that is meter square, minus, that is length is 50 and breadth is 10 m square. 2 into 150 plus 70 plus 105 m square minus 150 m square. So therefore 2 into this, add all this, we'll get 325 m square minus 150 m square, which is equal to 500. So 2 into 325 will become 650 m square minus 150 m square, which is equal to 500 m square. So we got surface area as 500 m square. Next is we have to calculate the number of, therefore number of cans is equal to, we have the formula, surface area to be painted, surface area to be painted by area painted by 1 can. So how much they have given? That is 100 m square. So we'll calculate this one. Surface area is 500 m square divided by area painted by 1 can is 100 m square. Substitute this, simplify, we will get 5. So therefore Daniel needs how many cans? That is 5 cans. 5 cans of paint to paint the room or the hall. Paint the room or all, anything. So this is the solution for the 5th problem. We'll move on to the next one, that is the 6th problem. So here the sixth problem is, describe how many two figures are at the right or alike and how they are different. Which box has larger lateral surface area? So two figures are given, that is we'll name it as figure 1 and figure 2. So how we have to just describe this as how different each are. So this one, so first figure is a cylinder and second one is a cube. So here both have same height. First point we have to write that is both, I'll write figure 1 and figure 2 have same height. Next is cylinder is solid by this one, that is figure 1 is a solid by revolving, by turning or revolving, by revolving a rectangular area about one side. So by revolving this cylinder, a rectangular area will be on one side. Therefore next is tube or figure 2 is a solid with and has 6 faces and has 6 faces. So how many? And this one has 6 faces. So cylinder has 2 circular faces. Cylinder has 2 circular faces. This one 6 square faces. I'll just write here. This one is circular, 2 circular faces. This is cylinder. So next we move on, that is upwards and downwards. Okay, next is we have wrote on the points. So next is figure 1. So R is equal to here 7 they have given, therefore radius 7 by 2 centimeters. Therefore H is equal to 7 centimeters. So next is we have to calculate surface area. Surface area will be given by the formula, that is 2 pi r h. So substitute the values, that is 2 into pi into r. Pi can be written as 22 by 7 into radius is 7 by 2. This one 7 by 2 into height is 7. Here this is radius, this is 7 by 2, and this is the height 7. So substitute here, then what we get, this cancels this 11. So 11 into 7 into 2 will get 440 m square. So this is about the figure 1 or the cylinder. So surface area will calculate now for figure 2, that is cube. See what are the data given. So all length is equal to 7 centimeters. They are given in the diagram. Breadth is 7 centimeters and height is 7 centimeters. So lateral surface area, lateral surface area is given as 4 into L square. So 4 into L square is equal to 4. Substitute L square. What is L here? 7 square, which is 4 into 49, which is equal to 196 centimeter square. This is I have done mistake here. This is 154 centimeter square. So here we are getting 196 centimeter square. Therefore finally we have to conclude what is the question is, which box has larger lateral surface. So finally, therefore the second figure or figure 2, that is cube, or we can also say box, has the larger, that is this one is 196 centimeter square, this one is 154 centimeter square, larger lateral surface area. So this is the answer for this 6th question. This is how to solve here. Write a few points, what are the difference between this figure 1 and figure 2, and then see the data, what are the data given, substitute the values, calculate the lateral surface area for this one, that is the figure 1 cylinder, calculate the lateral surface area for the figure 2. Then we'll find the difference which is having the lateral more or larger lateral surface area, that is the figure 2. Cube is having the larger lateral surface area. So this is the solution for the 6th question. We move on to the 7th one. 7th one, a closed cylindrical tank of radius 7 meter and height 3 meter is made from a sheet of metal. How many sheet of metal is required? A closed cylindrical tank of radius 7 meters, and height means this is a cylinder, closed cylinder. This one is of radius 7. This is height, that is 3 meter, and this one is 7 meters. So now is made from the sheet of, so it is made from, this cylinder is made from the sheet of metal. How many sheet of metal is required? So we have to find out. They have given radius is equal to 7 meters and height is equal to 3 meters. So total surface area is equal to, the formula given is 2 pi into r plus h. Therefore substitute the values, that is 2 into pi can be written as 22 by 7 into radius is 7 into 7 plus 3, that is r plus h. Height is given as 3. Now we'll simplify this, we'll get 440 m square. So finally, therefore, the metal, that is 440 m square of metal sheet is required. This is the solution. So how many metal sheet is required? That is 440 m square sheet, that is metal sheet is required. So this is the 7th question. We'll move on to the 8th one. So 8th question is, the lateral surface area of hollow cylinder is 4224 centimeter square. It is cut along its height and formed a rectangular sheet of width 33 centimeters. Find the perimeter of the rectangular sheet. So an lateral surface area of an hollow cylinder is given. So what are the data given? We'll first write down. So lateral surface area of the hollow cylinder. Hollow cylinder is how much? 4224 centimeter square. Therefore, next is area of the rectangular sheet is given as A is equal to WL, that is width into area is equal to width into length. The lateral surface area of the hollow cylinder is given. So we'll substitute here area. So area of the rectangular sheet is A is equal to WL. We'll substitute 4224 is given. W is how much? And the width is given here as 33 centimeters and area is given as 4224. Now we'll substitute here 33 into L. Therefore, L is equal to 4224 divided by 33. So we'll get 128 centimeters. Therefore, we are getting length as 128 centimeters. So this cylinder is cut along in the rectangular form, sheet form, with the width 33. So now we got the length as 128. Therefore we'll find out perimeter. So just understand the problem. There is a hollow cylinder and a sheet is cut in the rectangular form, and so we have to find out here the area is given, we have to find out the length, width is also given, so we found out the length. Next is the perimeter of the perimeter of the rectangular sheet. So formula given is P is equal to 2 into length plus width. So what we have, that is P is equal to 2. We have length as 128 we found out, and width given as 33 centimeters. So P is equal to 2 into, add these two, 161 centimeters. So P is equal to 322. Multiply these two, we'll get perimeter as 322 centimeters. Finally, therefore, the perimeter of the rectangular sheet is 322 centimeters. So we found out the length of the rectangular sheet and also the perimeter of the rectangular sheet. So this is the solution for the 8th problem. If you have any doubts, please comment me, subscribe my channel, share and like all the videos. Thank you.